Welcome, space explorers. Today, we're setting our sights on one of the most stunning and recognizable features in our solar system, Saturn's rings. These majestic rings have fascinated astronomers and stargazers for centuries. But there's much more to Saturn than just its rings. In this video, we'll dive deep into the mysteries of Saturn, exploring not only its magnificent rings, but also its intriguing moons, atmosphere, and magnetic field. So, strap in as we embark on a cosmic journey through Saturn's rings. And Saturn's rings are truly a wonder of the solar system. They were first observed by Galileo Galilei in 1610, although he could not discern their true nature. It wasn't until 1655 that Dutch astronomer Christian Huygens correctly identified them as a ring system. Saturn's rings are composed primarily of ice particles, ranging in size from tiny grains to massive boulders. These rings are divided into 7 main groups, named alphabetically in the order of their discovery: D, C, B, A, F, G, and E. Structure and composition. D ring. The innermost ring, faint and difficult to observe from Earth. C ring. Also known as the crepe ring, it's somewhat transparent and lies just inside the B ring. B ring. The brightest and most massive ring. It contains intricate structures known as spokes. A ring. Outside the B ring, it is separated by the Cassini division, a gap created by gravitational interactions with Saturn's moon Mimas. F ring. Narrow and twisted, located just outside the A ring, maintained by shepherd moons Pandora and Prometheus. G ring. Faint and narrow, discovered in 1980 by the Voyager spacecraft. E ring. The widest and faintest ring, composed mainly of ice particles from the moon Enceladus geysers. The exact origin of Saturn's rings remains a topic of scientific debate. Some theories suggest that they formed from the remnants of a shattered moon or comet, while others propose they could be as old as Saturn itself. The rings are not static. They are constantly changing due to gravitational interactions with Saturn's moons and the influence of meteoroid impacts. Saturn's atmosphere is a turbulent and dynamic environment, composed primarily of hydrogen and helium, with trace amounts of methane, ammonia, and other gases. The planet's rapid rotation, completing a spin every 10.7 hours, creates strong jet streams and banded cloud patterns, similar to those seen on Jupiter. Cloud layers. Upper atmosphere. Ammonia clouds form the highest visible layer, giving Saturn its pale yellow hue. Deeper layers. Beneath the ammonia clouds lie layers of ammonium hydrosulfide and water clouds, which are only visible through infrared observations. Storms and weather. Saturn is home to massive storms and long-lived atmospheric features. The most famous of these is the Great White Spot, a periodic storm that appears roughly every 30 years, covering almost the entire planet. These storms are thought to be driven by seasonal changes as Saturn orbits the Sun. Saturn has a diverse collection of moons, with 83 confirmed moons as of now. These moons vary widely in size, composition, and geological activity. Some of the most notable moons include Titan, the largest moon of Saturn and the second largest in the solar system. Titan has a thick atmosphere composed mainly of nitrogen and methane. It features lakes and rivers of liquid methane and ethane, as well as dunes and mountains. Titan's surface is shrouded in a dense haze, making it a prime target for future exploration. Enceladus, a small but active moon. Enceladus has geysers that erupt water vapor and ice particles from its subsurface ocean. These geysers contribute material to Saturn's E ring and make Enceladus one of the most promising places in the solar system to search for extraterrestrial life. Mimas, known for its large impact crater, Herschel, which gives it a striking resemblance to the Death Star from Star Wars. Rhea, Iapetus, and Dione. These moons show a variety of surface features, from impact craters to icy plains and ridges. Each of Saturn's moons offers a unique glimpse into the history and dynamics of the Saturnian system. Saturn's magnetic field, although not as strong as Jupiter's, is still powerful and complex. It is generated by the movement of metallic hydrogen within the planet's core. The magnetic field traps charged particles, creating a magnetosphere that extends far into space and interacts with the solar wind and Saturn's rings and moons. The magnetosphere of Saturn is home to intense radiation belts, which pose challenges for spacecraft. However, these belts also provide valuable data on the interactions between the planet, its rings, and its moons. The Cassini spacecraft, a joint mission by NASA, ESA, and ASI, orbited Saturn from 2004 to 2017, providing unprecedented insights into the planet and its system. Cassini's discoveries include detailed images and data on Saturn's rings, revealing their structure and dynamics. The discovery of active geysers on Enceladus and evidence of its subsurface ocean. Observations of Titan's surface and atmosphere, including its lakes and rivers of liquid hydrocarbons. Studies of Saturn's atmosphere, including the Great White Spot and other storms. Detailed mapping of Saturn's moons and their geological features. Cassini's mission ended with a dramatic plunge into Saturn's atmosphere, ensuring the spacecraft did not contaminate any of the potentially habitable moons. Saturn, with its majestic rings and diverse moons, continues to captivate scientists and space enthusiasts. Future missions, such as the Dragonfly mission to Titan, promise to unveil even more secrets about this fascinating planet and its system. As we explore Saturn and its wonders, we deepen our understanding of the solar system and the processes that shape it. Thank you for joining us on this journey through Saturn's rings and beyond. If you enjoyed this video, don't forget to like, comment, and subscribe for more captivating content about our universe. Stay curious and keep exploring.